Good morning. My name is Marnik van Klooster. I'm a professor at the Université Catholique de Louvain in Louvain-la-Neuve. There I'm working in the Bioscience Engineering faculty and in the Earth and Life Institute. From training, I'm an agri-engineer, but I always did my research within the area of hydrology, and I'm mainly working on hydrology, soil hydrology, and integrated water resources management related to agricultural production. And so today I will give you a lecture on climate change, adaptation and mitigation in the food system. Unfortunately, I cannot directly be with you due to different reasons, but we recorded this video, and I hope that by this recorded lecture you can go through the different materials of this course. The lecture aims to contribute to some of the learning outcomes that have been defined in the beginning of the course. And so if you go through the description of the course, you can see that there are a set of learning outcomes that have been defined. And so one of the learning outcomes is actually that when ending this summer school, you should be able to better understand the role of the food system in climate adaptation and mitigation in the Global South. And actually the lecture that I give today contributes to this learning outcome. Now, in order to set up my course, we go through a set of steps, and so we will try to give an answer to a set of questions. So we are going to talk about the food system, so we need first to define shortly what is the food system. Subsequently, we need, of course, to illustrate why it is so important to talk about the food system when discussing about climate change. Then, we need to try to set up some conceptual framework, and so we're going to try to define a conceptual framework which is well structured, which allows us to give a good description of what's going on in the food system, which encompasses as well social, economical aspects as physical aspects, and so therefore we're going to present such a framework. And then I'm going to talk about climate smart agriculture, because that's actually the answer that society and humanity can give to the big challenge of climate change and the food system. And subsequently, I will try to illustrate what is climate smart agriculture with two case studies with related to agricultural production in Africa, one in Tunisia and one in Western Africa in Benin. And hopefully at the end of this course, we can summarize some issues with some take-home messages. Now, there is, of course, some reading material that have been provided. This is just a selection of publications which gives a good overview of the current challenges related to climate change and the food system. Of course, there are a lot of other literature that is available. Just go to Scopus or Google Scholar or other scientific database, type in the word climate adaptation, climate mitigation, food sector, then you will come up with a lot of literature. And hereafter in my presentation, there will be also some references, scientific literature that will be given related to the material. Okay, let's directly start with the explanations of the different terms. So we are going to deal with the food system today. So first of all, we need to define what is a food system. Well, the food system is, of course, a complex system involving a lot of activities, a lot of actors, a lot of activities which are very relevant for humanity, but also for the economy, for sustaining life. Of course, we need to eat all day. Without food, we cannot survive. And the food system allows us to produce this food, to make it available, so that we can use it, so that we can create values based on that. Now, the food system encompasses different components, and one of the most important components is, of course, the food production system. It's actually agriculture, the agriculture sector, which produces vegetable and animal crops, and animal products which can be consumed. Then, of course, you have the processing, the transformation, the storage, the maintenance of the food, which is, of course, also a very important sector. Then there is, of course, the distribution and the retailing, and then finally you have the consumers. And actually, you have a lot of people working in the production sector. There are a lot of people dealing with the consuming. So we have nearly 7-8 billion people who are consuming food. There are 2 to 3 billion people who are producing food. And then there is a small set of actors, but which are also very important, which actually are concerned with the processing and the distribution of the food. Now, why is it important to look to the food system when talking about climate change? Well, the basis of the food system is, of course, food production. Food production is based on animal husbandry and vegetable crop production. And both the animal husbandry and the vegetable crop production relies on availability of natural resources and cannot be done without being affected by climate. On this map that you see here, you see actually 3 different constraints related to climate, physical constraints related to crop production, which is sunlight, water and temperature, which are all needed to be in optimal conditions in order to assure crop production. Now you see that, of course, the availability of water and availability of temperature and the availability of sunlight can be limited in different places. So for instance, if you go into the equatorial regions of the Amazon basin or the Congo basin, there light might be a limited factor for crop production because you have a lot of clouds. If you go to the desert regions in northern Africa or central Australia or southern Africa, there of course water is becoming a critical factor. And if you go into the polar regions, then of course there the temperature is not appropriate for assuring crop production. So you see that based on the places where you are in the world, you have different limited physical factors which creates constraints on crop production. Now, all these physical factors are, of course, strongly impacted by the climate. And so, if the climate will change, then, of course, temperature and water availability, also sunlight availability, will change. And that will, of course, have a very strong impact on the distribution of these factors, and therefore also on the potential crop production, which is a result of all these actions. Now, if you look to what the IPCC is telling us about the impact of climate change on food production and agriculture, while in one of the most recent reports, the IPCC is the Intergovernmental Panel of Climate Change, which provides a lot of information and which compiles the scientific information about climate change for different end users and for policymakers. Now, if you look to the reports that are published by IPCC, there was a recent report, a synthesis report that was published this year in March, where they again try to evaluate the impact of climate change on different sectors. So if you look now to this report, you can see that, for instance, climate change is already having impacts on agriculture sector, and if you look to the legend here, it will have adverse impacts. It will also have adverse impacts on fisheries. So these 2 components are extremely relevant for the food system, and so that means that climate change will have direct impact on the food system. So this is also illustrated, for instance, in this kind of figures, where some projections are made on how the expected climate change for different scenarios may have an impact on expected temperature, but also other properties. But what is very relevant for food production and agriculture is water that is available in the soil. So if you look to the soil water content or predicted soil water content in the future, when we will live in a world of an increase of 2 degrees Celsius or 3 degrees Celsius or 4 degrees Celsius, you see that this will all have a considerable impact on the variation of the soil moisture, and therefore it will create constraints on potential crop production. So climate change has a potential impact on food production. Another illustration of the IPCC report is, for instance, the predicted impacts on maize yield for different climate scenarios, from moderate modification until very strong modification of the temperature. You see that in the case you have, for instance, more than 4 degrees Celsius, you will have decreases of maize production, which is very considerably, up to 35, 40, 50% in many regions of the world. This will also have a very strong impact on the fishing potential and so fishery yields. So agriculture will be strongly impacted by climate change. But another reason why it is important to look to the food system is because agriculture itself is also a contributor to climate change, in the sense that a lot of greenhouse gases are actually emitted from the agriculture sector. Agriculture is done, of course, on natural soils. Soils are actually consuming a lot of organic material. Organic material is degrading, and this degradation of organic material contributes to the CO2 emission. Of course, you have crop production, which does photosynthesis, so there is a part of the CO2 that is also consumed, but there is a lot of CO2 that is also emitted from agriculture. So it's not only CO2 which is important, as explained in the course last week by Alexander Gelabert. There are also the nitrogen cycle that needs to be looked at, and so also agriculture activities has a strong impact on the nitrogen cycle and nitrogen fluxes, and some agricultural management practices increases the emission, for instance, of nitrogen oxides into the atmosphere, which is a very strong greenhouse gas. The same for methane, for instance. There are a lot of methane emitted, for instance, from rice cultivation systems when you are working in anaerobic conditions. So there is a lot of emission occurring also from the agriculture sector. So agriculture is contributing to the emission, and if we can, of course, control these emissions, then we can, of course, also contribute to the solution of the climate change problem. So agriculture and the food system is important to look at in climate change context because there are strong impacts and also because it actually contributes to the climate change. The next question that we can ask is, how can we frame the food-climate nexus? How can we actually compile all the information of this complex system such that it delivers us some reasonable information that can be used for setting up eventually actions, activities, which allow us to understand how it works, but also which allows us to define solutions for limiting the impacts of climate change on the food system and limiting the impact of the food system on the climate. And so for doing that, we are using a causal conceptual framework, which is called the DPCR framework. What is the DPCR framework? It is actually a framework which allows to synthesize information about complex systems into different components. We define components related to drivers, which are actually causing impacts on pressures, which subsequently will have an impact on the state of the system, and which finally will have an impact on the impact of the system on its environment, on its society. And subsequently we are going to define components which allows us to give responses of humanity and society on these working of the systems, which allows us to either reduce the pressure, improve the state of the system, or improving the impacts of the system. Now, this is maybe a little bit theoretically, so let's try to illustrate how that works in the case of the food-climate nexus. In this case, well, the driver which is actually having an impact on the system is a climate change, which, for instance, which will create pressures. So, for instance, if we think about crop productions, one of the pressures would be drought that is appearing. Now, if drought disappears, then of course it will result in variation of the state of the systems. And so one of the state variables could be the crop, which is subjected to stress, which will finally have an impact, which could be, for instance, a harvest that is not optimal, and we can have eventually some crop failure. Now, in order to try to solve this problem, we need, of course, to give a response. And so one of the responses that we can give in order to reduce these negative impacts in the causal links that exist between its different components is, for instance, in this case, climate smart agriculture. Climate smart agriculture allows us to develop actions. It can be physical actions, it can be management actions, it can be technological actions, but it can also be policy actions which allows to either to work on the pressures of the systems, or on the state of the systems, or on the impact of the systems, or if we indeed work, for instance, on mitigation, allows to reduce the driver and reduce the climate change. So this is actually a conceptual framework in which we can define actions that are produced by humanities. This is a framework that is very often used for describing complex, causally linked systems, environmental systems linked to societal systems. And so it is also very often used for setting up, for instance, information systems. So for policy making, we can imagine to define indicators which measures as well the drivers as the pressures, the state and the impact and the responses, and that these indicators are then used to measure, to quantify how responses could have an impact on droughts, and so on and so on. And so this information of indicators which are integrated in this kind of conceptual frameworks can be very precious for monitoring the evolution of the system. So we are going to try to work a little bit on that, and we are going mainly to look to the responses of how humanity can offer replies to, let's say, droughts and floods and all these kinds of climate change driving pressures, which creates serious stress on the food system and which have a lot of impacts, like, for instance, crop failure, harvest failure, hunger, and things like that. So we are going mainly to look to climate smart agriculture. What is climate smart agriculture? Well, actually, climate smart agriculture is an agriculture which is actually based on three different pillars. It is based on the fact that we need to increase the food production at a global scale. And the reason is very obvious. The population is still not constant, is still growing, and so that means that in the coming years we still need to increase the productivity of the global agriculture sector, of the food production system. It is expected by the FAO that by 2050 we need still to increase the global food production by 60%, so that's a lot. We need, of course, also, so that's the first pillar. We need to try to improve the productivity of the agriculture sector. We need also to adapt the agriculture sector to the new reality of climate change, increasing temperature, reducing precipitation, increasing droughts. So we need to take into consideration these constraints of climate change so that we can indeed increase the food security. And we need, of course, also to do agriculture in that context that allows us to contribute, let's say, to the mitigation, to the reduction of greenhouse gas emissions to the atmosphere from the agriculture sector. So these are the three pillars that are actually needed in order to set up climate smart agriculture. We need to work on issues related to production. We need to work on issues which allows to increase the resilience of the agriculture system and the food system. And we need to work on issues that allow us to reduce the emission of the food system. Now, the reason why we need to work on the productivity, I've already cited some numbers of the FAO very recently. So this is a figure that you can retrieve in one of the recommended reading materials, which is a report done by the World Bank in 2015. So we are now 2023, that's 8 years ago, and so there they are projecting the total food consumption that will increase by 2030 in comparison to 2015. So all these light orange blocks here are actually measures of the additional food production that is needed, here explained in trillions of kilocalories per day. And you see, of course, that this increase is dependent on the region in which you are. So, of course, in sub-Saharan Africa, there is a very strong expected population growth. So there is a very large amount of additional food production that is actually needed. But also in Asia, we have a lot of additional food production that is actually needed. So there is definitely a need for more for more productivity in the climate smart agriculture. We need also, with this climate smart agriculture, to face in a better way climate variability. Climate variability is something which occurs continuously, and so, for instance, here I illustrate with some work that we've done in Central Africa, where we actually try to map food production and let's say crop production in one province of a small country. Here it is for Burundi, where we're using satellite imagery for looking to global crop production for different years, and this is done here for 8 years, 2000 until 2007, and the colors are indicating the intensity of the crop production. And you see that, for instance, in the year 2000 there was a lot of droughts and there was a lack of crop production in this province. There were other years that were much more successful. So this is of course related to climate variability, which is also related to climate cycles which appears, like the El Nino, El Nina, and so all this kind of information can be documented. We can use it in order to establish this kind of maps, which illustrates that the temporal variability is very important, and that of course the climate smart agriculture needs to take into consideration this variability. We need to propose activities which allow us to face dry years and to try to use, of course, the optimal productions that has been made in very wet years. So we need to face the climate variability with this climate smart agriculture, but we need also to reduce the emission from the agriculture sector, and this is also illustrated in this figure. If you look to the total emissions into the atmosphere, and it's the carbon in the atmosphere which is of course contributing to the climate change impact, then we see that land use and agriculture production is actually contributing for 25%. So that's a lot. It's a very important sector, and so if we can reduce the emissions, the direct and the indirect emissions, but mainly the direct emissions coming from the agriculture sector in this area, then of course we contribute also to the global carbon targets that are defined by the different countries and by the United Nations. Okay, so that means that these are really three different challenges, three different dimensions of climate smart agriculture that we need to take up, and we are going to try to show you how this can be done. What's climate smart agriculture? Climate smart agriculture will therefore work on adaptations and mitigation options in order to improve the productivity, to increase the resilience, and in order to reduce the emission of carbon and other greenhouse gases from the agriculture sector. How can it be done? So this is also a figure which comes from the reading material. We can, of course, if you look to the food system, we can, of course, first of all look to the producers of food, which is the farmers and farming households. So they have a lot of options that they can actually activate in order to adapt their production systems. But there is, of course, also consumers, service providers, and agencies and policy, of course, which can be defined in order to promote some options, some actions which allows to adapt the food system to the changing climate. There are some of these options that are illustrated here, and which can be either incremental, transformational in terms of the intensity with which climate change will evolve in the future. And so some of these terms are explained here, and given the fact that we are dealing with an interdisciplinary school, it's interesting to explain you very shortly what all these terms are. So for instance, in terms of the food production sector, when you have let's say small changes of climate, we can think about developing crop production systems which are more tolerant to droughts and to wet conditions. So this is still a lot of research that can be done, but a lot of practices can be implemented. For instance, creating cultivars which will have root systems which goes much more deeper in the soil, which allows to validate and to use in a more efficient way the water and the nutrients which are also available deeper in the soil system, or which allows to reduce the emission of CO2. We can think about practices which is changing crop systems, and we will give some illustrations later on. So very often in traditional industrial agriculture there is a kind of a monoculture system that has been promoted mainly since the Second World War. Now, if you look now to this monoculture industrial agriculture, this is of course not very optimal in terms of greenhouse emission, in terms of carbon storage, and so there you can also do quite a lot of things by setting up, for instance, new crop cultivation systems, new crop rotation systems. For instance, you can imagine to set up cultures that between the major crop production, you set up other cultures which can also be used, which protects the soil, which allows to increase the carbon storage in the system. You can also go shifting out of agriculture. This is done in very many places. So for instance, in my country, in Belgium, there has been a reduction of the agricultural population, very strong reduction of the agricultural population since the Second World War. This is of course not only related to climate change, but due to the fact that the agriculture sector has become less attractive from an economical point of view. So there are a lot of farming options that can be made in order to adapt to climate change, but there is also a lot of options that can be provided by service providers or by policymakers, like for instance, getting financial resources available so that people can adapt, insurance systems that can be made available. Of course, also strategic planning, giving the opportunities to farmers to have access, for instance, to additional resources. So I'm thinking about, for instance, agriculture, water management, irrigation planning. So there are a lot of things that can be done at the national or regional level. So these are all kind of measures that can be taken by local or national policymakers in order to prepare the agriculture sector for adaptation when extreme or when climate change occurs. So there are a lot of adaptation actions that are possible. There are also a lot of mitigation actions that are actually possible, and this, therefore, I would like to refer to a very nice paper that has been published by Keith Bastian in Nature already some years ago, together with Pete Smith, and actually where they give a kind of a flow chart where they explain how soil can be managed, soil and agriculture can be managed in order to reduce the impact of agriculture as soil and land use on carbon emission and to greenhouse gas emission. And so they are actually using this kind of a flow chart, and they are looking to 9 different components in total, and they give options for mitigation for the different components, and you can go through this flow chart. And so I propose to take some time to go through that. So if you have a degraded or marginal land, so you have desert land or a very degraded land, so very little crop production there. So typically, if you are, for instance, in the semi-arid regions of the Mediterranean basin, well, in this case, well, you can try to do revegetation and convert this degraded land by perennial crops. These should not be directly agriculture productive crops, but it can be forests or things like that. If you have, for instance, soils that are drained, so this is typically what went on, for instance, in my country, so in Belgium, after the First World War, but in particularly after the Second World War, there has been a lot of land reclamation done, and there has been a lot of, let's say, wet soils that have been drained in order to make them productive for agriculture production. And so that means that a lot of wetlands, polder areas, has actually been lost and has been made available for doing agriculture production. Now, this have, of course, a strong impact on greenhouse emission, and so because then you create, for instance, the organic material that was not degraded because it was in anaerobic conditions. Then all of a sudden it becomes in oxidized conditions, and then all the organic material which is there can be oxidized, can be burned very fastly, and so that will create a very big push of carbon dioxide that actually becomes available in the atmosphere. This is similar to the problem of the permafrost. The permafrost, which is decreasing now. So when the permafrost is decreasing, then the organic material that was immobilized during a very long time becomes in oxidized conditions, and so the organic material can be mineralized by the organic material, by the microorganisms that are available in the soil, and so they will use this organic material to digest and to contribute to the production of CO2. So if we restore these wetlands, then we can contribute also to contribute to the mitigation of climate change in the agriculture sector. Then if there is a nutrient deficiency, then what does that mean? Well, if you have crops where you don't have optimal crop production, then of course this is not very good also for the CO2 emissions. It's better to have fields where the crop production is very high with very good canopies that are closed. Then you are using the resources in a very efficient way. And then if you are using the resources in an efficient way, then you create, of course, conditions which reduces the losses of trees, like losses of nitrogen in the crop system. And if you do that, then of course you will have an improved nitrogen balance in your agriculture systems. For bare soils, for instance, you can try to use these bare soils in order to use them as a potential for sequestration of carbon. So if you are putting vegetation on top of that, then you will use the CO2 that is captured by photosynthesis, and it will be injected into the soil system. So it's better not to have bare soils and vegetated soils. If you have excess of nutrients fertilizer, which is very often the case in industrialized agriculture, then you should reduce it again in order to avoid emissions of nitrogen to the atmosphere. If you have too much intensive tillage practices, then you will disturb the organic ecosystem of the soil, and that should also be halted by reducing the tillage and to try to restore and to keep as much as residue into the ecosystem. So we can also try to implement the residue retention as an option. We can also try to use enhanced efficiency of fertilizers, to try to work on a crop rotation, use of agroforestry and things like that. And then finally, if you have nutrient resources which are exogenous, like compost or organic matter, then of course you can try to use this organic material instead of mineral fertilizers to add them to agriculture systems, and that can be in the form of compost, but also in the form of biochar. Biochar is charcoal that has been created based on organic material, but it has a very long residence time in the soil, and so it degrades very slowly. It contributes to an improved soil structure, an improved ecosystem at the basis in the root zone of the crops. So if we implement all these actions, all these actions can actually contribute to the mitigation potential, and all these actions will also have co-benefits. And so, for instance, if you use, for instance, low residue crops, it will have co-benefits. It will also contribute to increase the biodiversity of the system. It will increase also the water quality. It will increase the soil health. So there are a lot of mitigation options that are available, and in the same publication that was published in Nature already some years ago, they are actually giving the potential of these different mitigation options. And of course, the potential should be in the area where you have a lot of potential emission reduction, where it can be applied on large surfaces. So for instance, use of biochar can be applied on a lot of surfaces, but the reduction potential is not so high. However, other things can contribute to rice management. For instance, we will come back to that later on. Rice management can have a very strong potential, 0.2 to 0.3 pentogram of carbon per year. So, well, this has a lot of potential, and it can be applied also on a very large area, not on extremely large, but a very large area. So we should try to go to these options here in order, and if possible, even retrieve options here in this area for improving, optimizing our mitigation potential. So there are practices that can be used in order to set up this climate smart agriculture to reduce the mitigation. That means in terms of, if you compare the conventional system where the CO2 absorption and emission is rather in equilibrium, with a smart agriculture we will try to increase the sequestration of the carbon. We will try to reduce the nitrogen oxide and the nitrogen emission as compared to what's going on into conventional systems. And the way how we can do that is by reducing tillage, by restoration of land, by improving the crop rotations, by adding organic amendments, by improving the nutrient management, by using cover crops, agroforestry. And in order to do that, we need, of course, a lot of science and technology in order to know exactly how that can be done. So we need, for instance, basic research on soil-plant interactions. For instance, how can we improve root systems of plants such that they actually will colonize better in the subsoil and better use the resources that are available and stock the carbon deeper in the soil. We need research networks, measurement networks, in order to monitor the carbon distribution in space and time. We need soil water monitoring networks in order to know how indeed these new practices can improve the water status. We need to use remote sensing. We need, of course, also therefore a lot of policy, and that's the reason why we are organizing this summer school, of course, because we do not only need these technical issues, we also need decision-making systems, planning, national policies, programs, gas mitigation programs, in order to come from this situation to that situation, which is much more appropriate and compatible with the changing climate. Now, in this figure, this is also coming from the reading material that has been proposed. You see, for instance, different options that are available for the different countries or the different parts of the world. So, for instance, here in Asia, you see you can. So the camembert diagrams which are here, the P is referring to the potential for increasing the productivity. The R is the potential for adaptation and increasing the resilience, and the E is referring to emissions, so the potential for reducing emissions and for climate mitigation. So, for instance, in rice, there is in Asia there is a very potential to work on AWD. AWD means that, and we'll come back to that immediately. It's a rice production system where we are not using continuous flooded rice, but where we are actually using alternative wetting and drying. So here you see well, the types of options that are available in Europe: manure management, livestock efficiency, pasture management, zero tillage. So these are all things that are very relevant in Europe. In Africa, agroforestry, pasture management, fertilizer applications. So these are all the kind of things that can be done. So let's try to go to two examples. So the first example of climate smart agriculture will be one that I'm taking from Tunisia. Tunisia is situated in the Mediterranean belt, and I do not have to explain you that the Mediterranean belt is actually subjected to very strong climate change. For this week, actually, there are meteorological predictions of having temperature up to 48 degrees in Sicilia, and so these heat waves are becoming extremely important, and it will have serious impacts on the living conditions in this area. some years ago, we were involved in projects allowing to make predictions for this region using downscaled and regional-based climate prediction models. And so this is, for instance, done a prediction that was made for one of the basins in which we were working at that time, which is the Shiba Basin. So what you see on this figure is actually the predicted climate change in terms of cumulative precipitation as compared to the reference. The reference is the period before 22. The future scenario is 2040-2070, and you see well that during summer periods you can have predicted reductions of precipitation of 20 to between 0 and 20%, but this is all negative, so that we are expecting less precipitation, and we are expecting, of course, also an increased temperature. And this is, of course, the results of an ensemble of downscaled climate scenarios. And so the interval, the gray interval, represents actually the uncertainty related to the different climate models that have been used. So here we are going to give you an illustration of how we can implement climate-smart agriculture in the Siliana catchment. Siliana catchment is situated in the central part of north center of Tunisia, and it is actually a catchment which is subjected to considerable climate change, to considerable land use change. Sorry. So here you see, for instance, a land use map of this catchment of 2013, and this is one of 2019. And so everything in yellow is field crop, and so this is mainly cereal production and forage production. And you see also in orange here the irrigated land. And so if you look here, for instance, for the 7 years, so based on satellite remote sensing imagery, you see that the irrigated land increased considerably. And so there are a lot of new irrigation parcels that comes in. And this is, of course, due to the fact that this region is already subjected to a lot of climate change, and due to the fact that the winter rainfall decreased already substantially. So the agriculture farmers in this region are actually developing irrigation in order to maintain agriculture productivity. Now, what is the strategy that can be followed in this case? Well, the strategy of the climate-smart agriculture strategy that can be followed is related to precision irrigation. What is precision irrigation? Well, it is irrigation that is based on a lot of knowledge of the crop water demand and the availability of water in the farming system at field scale. And so it allows to use the water where it is actually needed, and therefore, people are developing drip irrigation and micro sprinkling irrigation, which is considered to be much more efficient and which allows to put the water at the root zone of the plot and not providing it everywhere. And precision irrigation is also providing water when the crop is when the crop water requirements are very high, when there is a lot of need to do the irrigation. Now, in order to set up this precision irrigation, of course, if you do precision irrigation, it creates a lot of added value in terms of the 3 dimensions of climate-smart agriculture. It allows to increase the crop productivity, so it creates more crop per drop. It is also much more efficient in the use of resources. It uses less water in dry areas, so it makes it much more resilient because more water becomes available for other dry periods. And it also contributes to reduction of the greenhouse gases, because through precision irrigation you will reduce the losses of nutrients, and you will also reduce the conditions where soils becomes anaerobic, where you have a lot of denitrification and nitrogen emissions from the soil system. So it is actually contributing to the 3 dimensions of climate-smart agriculture. But in order to do that, you need, of course, to have a lot of information. You need to have climate information. You need to have, because you need to know when to irrigate. You need, therefore, to know how much water is needed. And you need to have sensor technologies in order to measure what is the actual status of the water. So it's like, it's like a medical doctor, you need to measure a lot of parameters of the body of interest. In this case, it is an agriculture field, and you try to apply the medical treatment on these places where the treatment is needed. So here it is with the water. So how can we do that? Well, we can do that, of course, by monitoring availability of water. So we have sensing technology available. These are the type of sensors that have been developed in the past. So these are just antennas which are forced into the soil. They are measuring a property of the soil which is called the electrical property, which is directly related to the soil water availability, to the soil water that is available in the root zone of the crop. And while this kind of information is collected and is transmitted by GPS technology towards a server where it can be collected continuously in time. And so by this type of technology, this is an example of 9 fields that are monitored in this catchment. We come up with this kind of graphs, which gives us information about how much water is available in the root zone of different fields. And then, of course, if the soil moisture becomes below a critical threshold, then we can say, okay, then we will start the irrigation. So this type of information is extremely precious and important in order to do precision agriculture. We can do the precision agriculture in time. We can do it also in space. So for instance, we can use information which is collected by remote sensing technology, which measures the evapotranspiration of the crops. So this is an example of measured actual evapotranspiration by different crops in this area. And if it becomes very red, then it becomes very evaporative, so very dry. So that means that at that time you need to add a lot of water. And so this type of information needs, of course, to be processed, but can be made available for the different farmers in order to do precision agriculture. A second illustration that I would like to give is related to rice production in Western Africa. Before to start to give that example, I show here a fact sheet related to rice production. Why do we look to that one? Well, rice production is important because it is the staple food for more than 3.5 billion people on the planet. It is also contributing to the economy and livelihoods of producers. 1 billion people are actually producing rice and or contributing to rice transformation. It is produced at a large surface area. It needs to increase by 25% over the 25 years in order to meet the global demand. But it has also a very strong impact on the environment. The rice farmers are, amongst others, the most vulnerable to adverse effects of climate change. They represent 50% of the world wetlands. They contribute very strongly to methane emissions, especially when you are using flooded rice. What is methane emission? What is actually going on is that if the soil is completely saturated, completely flooded, then of course there is no oxygen, then the organic matter that is available and the residues that enter in the soil, they cannot be completely degraded into CO2. But then there will be some metatroph bacteria that will develop in the root system of these rice crops, and they will actually mineralize the organic matter and create the methane that can contribute to the emission. And this is very important in terms of climate change because methane has a CO2 greenhouse effect which is much more larger than CO2. So it is responsible for 10% of the methane production, and it is also very responsible for the use of irrigation water. Agriculture is responsible for 80% of the freshwater use at global scale, and nearly 34 to 40% is actually consumed by rice production. So that means that the rice sector is a very important sector in terms of climate change. It is, of course, a sector that is very important in Asia, China, and India, which are the most populated countries of this planet. But they become also important in Western Africa, Nigeria, but also Central and Latin America, and also in the United States. So it is very important. And so one of the strategies that we can do is, instead of using rice crops with continuous wetting is to use alternative wetting and drying. So it is an alternative to continuous flowing, and it also contributes to the different dimensions of climate smart agriculture, because it will allow us to increase the yield, it will reduce the use of water because it uses larger water productivity, and it will reduce definitely the quantity of nitrogen that is emitted through denitrification in anaerobic conditions, as well as methane emissions. Now, in order to do that, you need, of course, also have the possibility to have access to climate information systems and soil information systems, and soil information sensor technologies, in order to know how dry the soil can become before you do the irrigation again. So this is just an example of what some analysis that recently was made in our group, where we did a meta-analysis of this kind of impacts of alternative wetting and drying. So we compiled the literature on that. We try to look what is the added value of alternating wetting drying based on the literature that is available. And so if you look, for instance, to this kind of figure illustrates what is the impact on yield and the impact on water productivity when different types of alternating wetting drying AWD strategies are used. And so what we can see that many of these strategies actually do not have strong impacts on yields. They may have even positive impacts on yields in some cases, but all of them are actually contributing to a positive impact in terms of water productivity, which is the parameter which measures the total amount of dry matter that is produced as compared to the water that is used. So that shows that AWD strategies in rice crop adaptation systems are actually extremely relevant for improving, for setting up climate smart agriculture. For doing that, you need, of course, to have information about what's going on in your system. So here we show some examples of what we are doing actually in Benin. In Benin, we are looking to this kind of rice production systems in what we call lowland valleys. And in these areas, we are actually installing a lot of sensors allowing to measure the climate, but also the availability of water, so that we can do the precision irrigation in a much more optimal way. We're also collecting information on the soil water status based on satellite imagery. And with this kind of information, we know exactly where the water is and when we need to apply water on a certain place and reduce the total water use in this kind of lowland production systems. Now this is of course based on satellite imagery. It is also needed to test this technology in order to see whether it is valid. So what we've done in this type of research environments is we installed also sensors in order to compare moisture content evolutions as measured by remote sensing data with sensors. And so you see here the results of measurements that were made by remote sensing technology and measurements that were made by local sensors that have been installed. And so you see that this might be consistent to some extent. And so that means that we have some potential to generate monitoring networks of water status in this kind of agriculture systems, which allows us therefore to use this information to optimize the AWD, the alternating wetting drying production systems in these kind of rice production systems. Now, with this, I think we gave some examples of what we can do in terms of climate smart agriculture. And I would like to finish my lecture with some take-home messages. So first of all, I would like that you remember that the food sector is really a key sector when we are discussing about climate change. And so a lot of issues related to policy should of course be related to policy and agriculture policy. Now, I hope that you would like also to take home the message that climate smart agriculture exists. It is pivotal to global sustainability, and it is based on 3 different dimensions: increasing the productivity, of agriculture, increasing the resilience capacity of agriculture, and also increasing the mitigation potential of agriculture. I hope that you will also take home a message that agriculture, water engineering, and management systems can contribute to this climate smart agriculture by improved monitoring of soil water, improved monitoring of nutrient availability and things like that. But of course, this should still be further developed, and there is quite some scope for research. So if you're interested to do agriculture research, you are very much welcome. But the reason why you are following this course is, of course, because of the fact that you're also interested in designing policy, and you will have the possibility to discuss about policy design in the future. So this policy design is definitely needed and needs to be optimized in order to implement climate smart agriculture. And with this, I would like to thank you for your attention, and I wish you a very continuous and prosperous continuation of this summer school. Thank you very much.